Today's video is about evaluating the logarithm. Question 4. Use log base a to the nth power of a to the mth power equals m over n to evaluate. For this formula, as long as you change the base and argument with the same base, the answer will be the quotient of exponents. For log base a of 1, we can write down log base a to the first power and a to the 0 power. So we have 0 over 1 equals 0. Natural log of e. Natural log base is e. E to the first power of e to the first power. 1 over 1 equals 1. Log base a of a to the nth power. We can write down a as a to the first power. So n over 1 equals n. Look at number 5. Evaluate the following without calculator by this formula. For b, natural log of 0.001, we can write down log base 10 of 10 to the negative third power. 10 we can write down 10 to the first power. Negative 3 over 1 will be negative 3. Look at the C, cubic root of 100. For cubic root of 100, that equals cubic root of 10 to the second power, which means 10 to the 2 over third power. Common log, the base is 10. 10 to the 2 over third power. This is 1. So 2 over 3 over 1 equals 2 over 3. For E, your goal is to make the same base for the base and the argument. Common log base is 10. 10 to the first power. For 100, we can write down 10 squared. Square root of 10, that is 10 to the 1/2 power. 2 minus 1 over 2 will be 10 to the 1.5 power, equals 1.5 over 1 is 1.5. Let's go to J, common log of 1 over 4th root of 10. Log base 10 of 10 to the negative 1 over 4th power. For 1 over, which means the exponent is negative. So we have negative 1 over 4. Let's look at the H. Log base 10, because this is a common log. 10 to the third power times 10 to the 1/2 power. Multiplication of a power, we add exponents. 3 plus 1/2 will be 10 to the 3.5 power. This is 1. So we have 3.5 over 1 equals 3.5. Let's go to L. Natural log, we know the base is E. 1 over square root of E will be E to the negative 1/2 power. For E, we can write down E to the first power. So your answer will be negative 1 over 2. Let's go to M. Log base 4 of 1 over 2 square root of 2. We will make a same base. 4, we can write down 2 to the second power. 2 square root of 2, that is 2 to the first power times 2 to the 1/2 power. This is a multiplication of a power. We add exponents. 3 over 2. 1 over, which means the exponents will be negative. So we write down 2 to the negative 3 over second power equals negative 3 over 2 over 2. Drop down, that is negative 3 over 4. Let's go to O. Log base 3 of 1 over square root of 27. Square root of 27, we can write down square root 3 to the third power. Square root, this is 2. So we have 3 to the 3 over second power. 1 over, which means negative exponents. So we write down log base 3 to the first power of 3 to the negative 3 over second power. Then the answer will be negative 3 over 2 over 1 will be negative 3 over 2. Let's go to number 6, A. Log base 1 over 25 of square root 125. We will create the same base for the base and the argument. That will be 5. Log 1 over 25, that is 5 to the negative second power. Square root of 125. 125 is 5 to the third power. Square root, this is 2, which means 5 to the 3 over second power. So we write down 5, 3 over second power. That equals 3 over 2 over negative 2. Denominator drop down. Answer will be negative 3 over 4. Let's go to D. We will make a same base for the base and the argument. Log 1 over 27, that is 3 to the negative third power. Cubic root of 81, that is cubic root of 3 to the fourth power, which means 3 to the 4 over third power equals 4 over 3 over negative 3. Then you drop down, equals negative 4 over 9. For J, the same base will be 2. Fifth root of 16, which means fifth root of 2 to the fourth power. So we have 2 to the 4 over fifth power. 1 over 8, that is 2 to the negative third power, equals negative 3 over 4 over 5. Denominator jump up, that equals negative 15 over 4. Look at the J. We know log base B of C times log base C of P times log base P of A equals log base B of A. Therefore, we will get 8877 is gone. Log base 3 of 81 equals log base 3 to the first power. 81, that is 3 to the fourth power. 4 over 1 equals 4. Let's go to number 7. Evaluate each log. Using the backwards of change of base formula. For A, common log of 32 over common log of 2, that is log base 2 of 32. So we will change the same base for the base and argument. 2 to the first power, 2 to the fifth power. 5 over 1 equals 5. Look at the D. Using the backwards of change of base formula, we will get log base 0.2 of 25. For 0.2, we will change it into 1 over 5. 1 over 5, that is 5 to the negative first power. So we get log base 5 to the negative first power of 5 squared. 2 over negative 1 is negative 2. Look at the F. Backwards of change of base formula. Log base 0.25 of 8. 0.25, that equals 1 over 4. That equals 2 to the negative second power. So we write down log base 2 to the negative second power. 8 will be 2 to the third power. That equals 3 over negative 2 equals negative 3 over 2. For number 8, we will use inverse property of log. A to the power of log base A of x equals x for x greater than 0 to evaluate the following expressions. Let's analyze this formula. When this base and the base of logarithm are equal, we will get x. Therefore, for A, 3 equals 7. Look at the C. We have this is 3, this is 9. We will make the same base. Remember, we have this formula, log base B of A equals log base B to the nth power of A to the nth power. We will use this property. So equals 3 state log. This 9, I will change into 3 by doing square root. So square root of 9, then square root of 10. Square root means we will do the 1/2 power. So we get 3 log base 3 of square root of 10. Answer will be square root of 10. Look at the D. The base are not the same. We will try to create the same base. So we have 16 log. For 2 to the fourth power will be 16. Then we will do 5 to the fourth power equals 16 to the power of log base 16 of 5 to the fourth power equals 5 to the fourth power equals 625.